So guys, I'll be solving today a sample question or some questions from chapter 18 regarding the nucleus. And this is a sample question, so it's the basis of whatever we've done. We are to calculate the bonding energy of lead. Okay? And the bonding energy per nucleon also. The bonding energy per nucleon is... The bonding energy of a nucleus is delta M times C squared. With delta M, the mass defect or the mass deficit is the mass of the nucleons minus the mass of the nucleus itself. The mass of the nucleons, now let's take a look at lead and C. Lead has 82 protons and it has 208 minus 82 neutrons, all in all, minus the mass of the nucleus itself. Now, let's take a look at those. 82 protons, and the mass of each proton is given to you guys, 1.00727, this is given to you. So don't worry about it that much. 208 minus 82, that would be, I guess, 126 neutrons, and the mass of a neutron is given as 1.00866, that is again given to you. Now, all those are given, minus the mass of a nucleus of lead, 207, which is also given, 97664. And if I do the math, this would be 1.71068 atomic mass units. Okay? And this is delta M, the mass defect in AMU. To change that into energy, that would be delta M times C squared. With delta M being 1.71068 times the magical number 931.5 MeV per C squared, and we have that C squared. So you'd end up having, I would guess, 1.7 times 931.5 and 931.5, that would be 1593.5 MeV. This is the bonding energy for lead, and they want the bonding energy per nucleon for lead. So 1593 MeV are used to bind 208 nucleons together, because lead has 208 nucleons altogether. And that answer would be divided by 208. It would be 7.66 mega electron volt per nucleon. Alright, that is it. And if I were to ask you to plot, just label lead on that, on Aston's curve, which looks like that. Do you remember the curve for stability? The bonding energy per A. So with 8 MeV being per nucleon being the limit of stability, you would find lead to be somewhere over here. Okay, this is the bordering the 190-200 limit, okay, for stable elements, and that would be lead over here. Okay.